Okay, welcome to this unit test from the textbook of the Delta 2 series on chapter 10. This is about graphs and functions. We're going to whiz through this in a quicker time as we can. Draw a coordinate grid with x and y coordinates from -10 to 10. That's been done already. Draw the graph 3x plus 2y equals 1. Okay, so what I'm going to do is rearrange that equation so it's of the form y equals mx plus c. Okay, and we can see the gradient then as m and the y-axis intercept as c. Okay, so what we're going to do is we're going to take away 3x from both sides. So I'll do it here. So I've got 2y must be equal to 1 minus 3x, or minus 3x plus 1. Same thing, it just looks more like this if we put the minus 3x first. Divide both sides by 2, we get y equals negative 3 over 2x, which is like negative 1.5x plus a half, because we've divided both sides by 2. Okay, well, what does that look like? Well, it crosses the y-axis at a half, which is here. Okay, that's what the plus a half means. I'll just put a little mark there. And it has a gradient of negative 1.5. So for every 2 we go across, we go down 3. So it's got a gradient like that. Okay, so 2 across and down 1, 2, 3. Okay, so it's coming through here, 2 across, 1, 2, 3. So it's coming from about here. I'm going to start here, go through that point, and it's continuing up there like that. Okay, so that's the line with equation 2y plus 3x equals 1. Okay, find the inverse function of each of these. Well, all we do is reverse it. So to get from x, we had to multiply it by 3. That's 3x. So the reverse of that is to divide it by 3. Okay, so the answer to part A is just x maps on to x over 3. I'll do them over here. So A is x maps on to a third x, or x over 3. Okay, it's very easy to see that one. The second one, B, is x maps onto 2x minus 5. Just follow the flow chart. Look, this is part B. I'll do it here. Okay, so we start with x. The first thing we do to it is times it by 2. Okay, so x times 2, and then we subtract 5, and it gives us our answer, which we'll call y. Okay, if we go back the other way, then we do the opposite. We add 5 and then we divide by 2. Okay, and that will give us back to where we started from, x. So what I can do is I can say that the inverse function is x maps onto, and I replace this now with x plus 5 over 2, x plus 5, okay, over 2, and that's the answer, working backwards this way to where I started. Okay, in C, I'm adding 1 to x, then multiplying by 3. So the opposite is to divide by 3 and then subtract 1. So the inverse of this one is x maps onto, this is C, so x maps onto, so I do the opposite of that. So I times by 3, so I divide by 3 and then subtract 1. Okay, and part D comes to, well, the opposite of adding 7 is subtracting 7. So D is that x maps onto x minus 7. And E is, well, you've got y equals 3x minus 2. So you're timesing by 3, then subtracting 2. So the opposite is to add 2 and divide by 3. So E is that x maps onto x plus 2 and then divide by 3. Okay, and that's the answer to question 2. Question 3, write the equation of this line. Well, it's got a gradient of 3 and it goes through the point 0, 0. So for every 2 you go across, you go up 6. Got a gradient of 3. It's simply the line y equals 3x plus 0, if you like, which is just y equals 3x. Okay, next question. 4. Where does the line y equals 3x minus 5 cross the y-axis? Easy, minus 5. That is the y-axis intercept, and this number 3 is the gradient. What is the gradient of the line y equals minus 2x plus 7? Well, the gradient is the number in front of x, which is minus 2. Don't write minus 2x, just minus 2. Is the line A, B, or C the inverse function of 2x plus 5? Right. What you need to understand here is that the inverse of a function is a reflection of the function in the line y equals x. If I draw the line y equals x here, I'll do this in yellow. So it's this line here, okay? This is the line with equation y equals x, all right? Now, the line that's reflected, so the blue line is 2x plus 5. The orange line is a reflection of that in the line y equals x. So if I took that blue line and flipped it over, it would sit where that orange line is. So it's line B is the answer. Okay, so that's the answer there, B. Okay, next question. Number 6, a line has a gradient of 4 and intercepts the y-axis at 0, negative 3. Write the equation of the line. All you need to write is y equals 4x, okay, because the gradient is 4, and it crosses the y-axis at the point 0, minus 3. So it's there. It's like it's crossing here at this point here, 0, minus 3, with a gradient of 4. Okay, number 7. Does the point 6, 2 lie on the line that? This is what you do. Okay, these numbers here are x and y coordinates. So what you do is you take the x coordinate, which is 6, and you put it into this equation and see if it gives you 2 for the y coordinate. So what I do is I take this and I say y equals 2 lots of 6, okay, minus 14. Now that comes to 2 times 6 is 12, minus 14 is minus 2. So that tells me if the x coordinate is 6 on this line, then the y coordinate would have to be minus 2. But this one isn't, it's 2. So therefore the point 6, 2 is not on the line. Not on the line. Okay? And you've explained it by doing this working here. Number 8, work out the gradient of the line joining the points 1, 5 and 3, negative 3. Now you can easily work it out. What you do is you subtract the y coordinates from each other and then the x coordinates in the same order. So the gradient is minus 3 minus 5. Okay, so I'm going from right to left. Minus 3 minus 5. So that's the subtraction of the two y coordinates divided by, okay, divided by the subtraction of the x coordinates in the same order, which is 3 minus 3 minus 5, and then I've got 3 minus 1, yeah, 3 minus 1, which is 2. So that on the top is minus 8, and on the bottom is 3 minus 1 is 2. Well, negative 8 over 2 is the same as negative 4 over 1, which is just negative 4. So that's the gradient of the line linking those 2 points. If you did a little sketch, it would look something like this, just to give you a rough idea. So you've got your y-axis and your x-axis. You've got those 2 points. Okay, so 1, 5 is about there. Okay, roughly, this is just a sketch. Okay, and then you've got this other point here, 3, -3, which is about there. Okay, and what it's telling me is that this gradient of the line connecting those two is about -4. Okay, so it's a steep downhill line, and you can see that's about right. Okay, but that's how you mathematically work it out. Next question. Okay, number 9, the graph shows the relationship between the length of the edges of a cube and the surface area of the cube. Use the graph to estimate the surface area when the edges are 2.5. All you do is this, but show the working out by drawing it on the graph. So the length of the edge is 2.5, so it's about there. Draw a line up, hit the curve, and then come across and read off what you get. I reckon that is about 30, well, it's between 25 and 50. It's about 37, 38, maybe something like that. They will allow a certain tolerance. I'm going to put 38 because it's just a bit more than halfway between those two. Okay, so 38 centimeters cubed for this one. Okay, that's number 9. They'll allow a tolerance there because of the reading of the graph. Number 10, the graph shows the total amount in an investment fund over 12 years. What's the initial investment? Well, the initial investment was £10,000 because that was at the beginning of the time period. So that's easy, £10,000. Okay, that goes in there. The second question, how much did the investment increase by each year for the first 10 years? Well, it went from 10,000 to 11,000 over 10 years. Okay, so it increased by 1,000 over 10 years. So how much did it increase by each year? So it was 11,000, right, minus 10,000, right, which equals 1,000. Okay, and that had to be divided by 10 because it's over 10 years. So that means £100 per year is what it increased by for 10 years. Okay, what happened to the investment after 10 years? Well, after 10 years, it stopped increasing, okay, because the line just goes flat. So it stopped increasing for whatever reason, okay. It stayed the same, in other words. I suppose you could say it stopped, it didn't decrease either, it just stayed the same. That might be a better answer. Okay, and number 11, which of these statements are true? Right. Are these two lines parallel? No, because if they were, they would have to have the same gradient. This has a gradient of 2, that has a gradient of -2. Are these perpendicular? Yes, because the gradient of that one is the negative reciprocal of that. So take the number 2, write it as 1 over 2 and change the sign, and it gives you a line that's perpendicular at 90 degrees. Basically, one of those lines has a gradient of 2, okay, which is about that. The other has a gradient of -1/2, which is about that. They're at 90 degrees to each other. Okay, the other way of showing it is that if you multiply the two gradients together and the answer is -1, then it means that one is the negative reciprocal of the other and they are perpendicular. Okay. C, the lines 2x and 1/2x are parallel. No, because they have different gradients. 2x and a half x are perpendicular? No, because one of those would have to be negative. 2x and 2x plus 1 are parallel? Yes, because they both have a gradient of 2. And 2x and 2x plus 1 are perpendicular? Well, no, because if they're parallel, they can't be perpendicular. So the correct ones are B and E. Finally, the last question. Okay, number 12. The graph of y equals minus 2x plus 5 is shown. What's the equation of line A? Well, it must be y equals minus 2x because it's the same gradient, because it's parallel. So it must start with that. But what about the plus 5? Well, there's the plus 5 for the blue line. Ours goes through the axis at plus 1. So it's simply minus 2x plus 1. That's the equation of the line A. That's the end of that little test. 16 minutes. Pause the video and go back over the bits you didn't get. Take care.